This is Tips and Tricks Part 1, part of the Address User Day 2015. Part 1 will look at useful application options that are available inside of Inventor. We're also going to be looking at multi-body workflow from start to finish. So creating a part that represents an assembly and then generating an assembly from it. How we can use iLogic to extract cutting information. Various right-click options that exist throughout the program. And assembly tips, which we'll be looking at flexible assemblies, dynamic positional reps, constraints, and clash detection. Okay, so in part 1 we're going to be using this front loader as our example. We're going to be focusing on the front section of this loader. So what we're going to be doing is creating a multi-body that links the boom to this center pivot bracket. So it's going to be made up of several components, and we're going to use the multi-body technique to generate those parts. So we're going to start from scratch. So multi-bodies, you start in a part file, and all a multi-body is the ability to create individual solids in a single part file. Before we jump into it, I just wanted to go through a couple of application options. Now you'll notice the background and the color scheme that I've currently got applied. So I've got winter night, which is the default after a new installation. So personally, I prefer to use presentation mode. So I can go to the colors tab in my application options, go to presentation, and I can set my background color to one color. So that gives me a solid white background. And for a lot of users, they like a lot of the backgrounds they use, but they don't like the color schemes applied against them. So we can see that my sketch geometry is blue for constrained, black for unconstrained, projected is yellow, and my dimensional constraints are blue. Now I quite like the scheme that is applied to deep blue. I like the green geometry and the orange dimensions and orange projected geometry, but I prefer to apply it against a white background. And you can do this. So the tip is, rather than setting it to one color, so select the scheme you want. On the background section, if we set background image, we can actually browse to an image that we want. So you'll notice that I've got one in here called white background. So it's not in there by default, I've placed it in. So to generate that background was very simple. All I've done is from my Windows start bar, I've gone into paint mode. In paint mode, I've then saved my image, called it white background. Once I've saved it, I've then done a copy or a cut and paste into my backgrounds folder for Inventor. If I then apply, I get the color scheme I want with the background I want. So another tip I wanted to go through was dimensional constraints and geometric constraints. So we can see at the moment the size they are on the screen. So for a lot of people, resolutions of screens have got bigger, screens have got bigger. So people have quite high resolutions, and obviously icons become small, like our dimensions. You can actually scale up your dimensions and your constraints. So you can now do this under the General tab. So in 2015 they've actually combined the two features together, so dimensions and geometric constraints are controlled under one section. This annotation scale, if I change it and apply, so 1.5 will make it 50% larger than its original. If I apply that, we can see the dimensions and our geometric constraints have increased. So again, just a quick tip there. So I'm ready to start creating my multi-body now. So what I'm going to start to do is finish the dimensions required. And I'm going to use my right click. I'm going to go and use my general dimension. So use your marking menu. It's a really useful tool. It's definitely underused. Again, I'm finishing my sketch using my marking menu, extruding using my marking menu. So all the time I can access a lot of my options on the marking menu. It's a really productive tool. People should be using it. So what we're going to do is create multiple solids. So a multibody is creating multiple solids in a single part file. So you can start to reuse sketches. We don't have to start to transfer sketches between files. That's one advantage straight away of using multibodies. So to create a multibody, all you do when you're using your standard modeling tools is to select this icon. Whenever you see this icon, it means you can create a new solid. And it's as simple as that. As soon as I OK that, what I'll get is, in my model browser, I have a solid body folder, and we can see we've now got two solids. I can start to rename these solids to represent descriptions of my parts, what will potentially be my finished part name or part number. So we're going to carry on creating a few more solids. So I have a pre-created sketch here. Again, I'm going to use my marking menu to access. Now notice that we can create a new solid. Again, once we OK, we get another solid in the browser which we can rename. We can also start to mirror solids as well. So I'm going to select my plane command. Now notice when you select the plane command, often people struggle with selecting objects because it picks up so many entities. Just remember that you've now got a filter which you can use. The filter will restrict what you can select, making it a lot easier to achieve the command you're after, like a mid between two planes. I also need to create an offset plane. Notice that I had to return back. Just remember that when you start the work feature command, any of them, you can actually switch on repeat. That will just mean that I won't have to go back to the interface. I can just repeat creating planes. So in this example, we just want one plane. And again, I'm going to create a new sketch using my marking menu. Now, just a tip, remember at the bottom on your status bar you have the ability to slice graphics. If you're using multibodies, you will need to use this. Slice graphics will remove anything that's obstructing your view. What I'm also going to do is start to project geometry. Again, I can access it on my marking menu. I can start to access various tools like my circle and line command from the marking menu. I can start to create relationships again. So just another tip, if you control right click, it brings up your sub marking menu. In this example, my sub marking menu is my geometric constraints. So I can, in this example, apply an equal, and again go to my main marking menu and apply a constraint. Again, if you want to go into construction mode, you can do it on the right click, this time on the sub menu. If we need to exit that, we can do it on the right click. I'm getting to all of my most common commands by using control right click or right click to access my marking menu. And again, just dimensioning. So I also want to create some additional lines. Remember that if you hold the shift command, you can enforce tangency, which means I can create tangency at 2 points without having to apply a constraint afterwards. But remember, we can always apply a constraint afterwards by using the control right click command if we need to. Okay, so next tip is I'm going to start using my trim command, again using the marking menu. And you'll notice that it's actually giving me feedback in the left hand corner. So the bottom left on the status bar, you'll always get feedback from all your commands. It's now telling me to select portion of curved trim or press and hold control key. So often this feedback is lost because we don't look at the status bar. So as a tip, if you want to get feedback, you can have it at cursor level. It's called dynamic prompts. Under the Tools tab, Application Options, we can go to our General tab, and we have a section called Prompting Interaction. Under there we can switch on something called Dynamic Prompts. What this means is we now get prompts at cursor level. So now we can see at my cursor it's telling me what to do. So a lot more obvious. A lot of the time we're often waiting, not knowing what to do next. If we use the dynamic prompts, it's easier to identify. So a tip with the trim command is if we hold Control, we can set a region when using the trim tool. So rather than having to trim 3 times, like in this example, to get rid of the circle, I could have used my Control key to set a region. So Control and click the 2 objects. Once I click the object to trim, it knows to trim between those 2 objects. So hold Control and then trim. Hold Control and then trim the object. So a more efficient way of being able to trim our geometry. Again, I'm coming out of my marking menu and using my extrude tool and creating a new solid. So whenever you see that icon, you can create a separate solid. I'm also going to start to mirror these components now, so I'm going to use my mirror tool, and when we mirror, we can also mirror a new solid. So as long as we select this, we have a new solid. And again, I'm just going to switch off my planes, and I have my component. So the other thing I wanted to go through was this chrome effect that's currently being applied. Some users prefer a nice, consistent, even chrome finish or a reflective finish. Currently, a theme called Parking Lot is being applied. So again, a tip, if you don't like this reflective environment, you can change it within your application options. So under Tools, in our application options, we can go to the Colors tab again, and you can see we have the section called Reflection Environment. If we browse, we can specify a different finish. So you can actually use the supplied files, or you can switch to all files, and there are bitmaps available. You can create your own reflection environment as well, as long as it's a bitmap. In this example, I'm going to use Chrome, and if I apply, we can see we now get a nice, even reflective finish. So I've got my completed multibody. This is everything that I need currently. There's nothing more to do in this example. So before we actually generate an assembly from this, I wanted to discuss what you could do with what you have so far. So as a multibody file, I could use this in the assembly as it is. So if there's no requirement to create a parts list that identifies each and every component, then I could just use what I've got here. It might be that the part file, whatever the top level item number is, that is enough to represent whatever I'm using. I don't need to break each part down. If I needed to create a parts list and identify each and every part, then I would need to use the next tool. So this can be very useful if you're modeling up, you want to model up representations of assemblies without generating each and every part. Like I say, we want all of these to be broken into parts. So to do this, we use a command called Make Components. It's on the Manage tab, on the Layout panel, and then you've got Make Components. So this works by selecting the bodies from the graphics window or the model browser. We can specify where we want to save the files, and what it will also do, if we want it to, is create an assembly. So that is optional, and I do want to put all of these parts into an assembly. So the next section, when we click Next, is to identify the body name and the component name. So you'll notice the reason that I've named my bodies is because they will become the component name. We can still override them at this point, but I'm happy with what I've got. We can also start to override things like bomb structure, where the file is going to get saved, and also template. So if some of these files are to become sheet metal, I can specify that. Or like in this example, I'm going to use a specific part template that might have certain properties or logic that I need to utilize. So I've actually got an iLogic template that extracts cutting information, length, width and thickness. In this example, we're not going to show you how to do it. If you're interested, get in touch and we might put a video online or put some code online for how we extracted cutting information from these parts using logic. So once I've specified my templates, if I click OK, it will turn each of these bodies into individual parts and put them in an assembly. So we're now looking at the assembly file. So you can see we're in the assembly environment. Each part is grounded. So another advantage is no constraints. There are no constraints because they're modeled in place. Everything references back to the original file, so if we update it, it's going to update this assembly. So another little tip is restructuring an assembly. Now in this example, some of these parts should be in a sub-assembly, but obviously the Make Components tool didn't give me that option. So you can select parts, and on the right click you can do something called a component demote. It will demote all the selected parts and generate a new assembly. So we get this in place dialog where I can assign a new assembly number, tell it the assembly type, where I want to save it, and its structure. Once I click OK, it reorganizes. Now, if you're using traditional modeling techniques and constraining objects, in most cases it will maintain those constraints. Because we're using multibodies, we need to remember to ground it afterwards, because there are no constraints. And in this example, I've actually restructured it incorrectly. I've missed a component. Again, if you have existing assemblies that you want to restructure to, simply do a drag and drop. So you can restructure by drag and drop. Similarly, if we restructure incorrectly, again we can lift them out by doing a drag and drop. And finally, within this multi-body example, just to show you the cutting information that we've extracted, when we go to the Manage tab, on our Manage panel we have our bill of materials. If we take a look, once I've done a save that is, in the parts that we've applied our template to, we're now getting length, width and thickness. So just a little tip there. So there's lots of functions that we can use logic for. So this is ready to go into my assembly. So another quick tip, if we right click in the browser we can do a copy. We can actually paste it into our assembly. So I'm pasting it in position and I'm going to start constraining it. Again, I'm starting to access my constrain tool from the marking menu and I'm going to constrain it in position. Now you can see I've made some fundamental mistakes in this particular example, that this unit is nowhere near wide enough. So in fact the gap between these two plates are meant to be at least 237, and the overall size, if we were to measure the boom, it's meant to be 1 meter. So we're going to go back and again try and highlight some of the multi-body advantages. So the multi-body is still driven and controlled from the original file. So I've switched back to the original file now and we can see the feature history. So I'm going to update its sizes. So you'll notice that I'm going to change the size now to 1 meter. And I'm going to change the spacing between these two plates, which is just a case of editing my work plane, to 237 divided by 2. So we'll make it 238 in this example. Oops. This is 238 divided by 2. So that's given me the gap that I require. with a mill clearance. So I can start using this now. So I've saved this master file, so this will update all of the parts in the assembly that I've created. So it still hasn't quite updated, we can still see it's the same. All we do is do a local update of our assembly and it will refresh our components, and you can see it's now changed to the size it should be. So one of the advantages is we have a central file that can drive and change all of the components, and we don't have to worry about constraints because everything's modeled in place. So that's multibodies, or an introduction to multibodies. So I'm going to take this out now because I don't actually need it. I already have something in place. So the next example we're going to go through is placing a hydraulic ram in position between the pivot arm and the main structure. So we're going to open that up. Okay, so in this example, I wanted to go through something that was introduced in 2011. So I want to apply a constraint. So a lot of users often ask if there's a way of being able to set movement within a device. So we want to leave it kind of flexible. So the answer is you can. It's been available since 2011 and it's called limits. So what we can actually do is, I have an existing constraint and you can see it's got a 10 mm offset from the head of this ram to the cap, joins up the main hydraulic system. So we're going to edit this constraint, and you can create limits simply when you're creating the constraint or when you're editing afterwards by clicking on this icon. So the chevron symbol will expand the dialog. So one thing you can do, even if you're not going to use limits, is rename a constraint from your dialog now. And there we go. So we actually do want to set limits. So you'll notice in the bottom half we can set a maximum and a minimum distance, which in this example is maximum 650, minimum 10. What this means now is the constraint gets a symbol against it, which is a plus and minus to represent limits, and I can move it between the specified range. You may say, well, that's great, but when we've created drawings, they're going to be affected by what you're doing if you're leaving it open to change. So you may want it to be flexible, but you always want it to return to a set position so it doesn't affect things. Or you may have a natural resting position for a device. So simply when you're creating or editing the constraint, you can tick this box, which is use offset as resting position. So what that means is, in the offset section of our constraint dialog, we can specify what is the resting position, which in this example I've set to 10, which means I can move it between the specified values. If I release it, it goes to the resting position. So again, just a quick tip there. So you may then say, well, that's great, I've got some limits, but I also want set positions. Maybe within a drawing or in the assembly I want to illustrate different cycles that it goes through. So open, closed, and halfway open. You can do this by using something called positional representations. Under the representations folder, you have some position, and you can see we have some already created. I have extended, retracted, and a couple of other ones. So I want to create a new one which shows halfway through its cycle. So all we do is simply right click on position and create a new one. We can rename our positional rep. And to set it, all we do is find the constraint, and you do something called an override on the right click menu, and we enable our value and set it. So in this example I want it to be halfway, and it's as simple as that. You can override multiple constraints within the positional representation tool as well. So now we have master, retracted, extended, halfway. So useful tool. So we're now going to place this into the front section of our loader. So again, I've just done a copy and paste to speed up the process, and I'm going to constrain this in position. So that's constrained in position. If we take a look at what we have, you'll notice that I'm unable to move it. So if we just get a better angle, when I try to move this, it's not letting me move it. So if you think about it, a lot of the times, you may come across it at the point where you want to bring in something, and we have a lot of customers that bring this up. We have assemblies that are flexible, so they change based on what they're being placed onto, like in this example. So we need it to be flexible. We know in the assembly that we've created it in, we have that flexibility, but we want to promote it. So if you want to promote degrees of freedom, you simply right click on the item, either from the browser or the window, and you make flexible. By making flexible, it promotes any degrees of freedom. So you can see now we can move it. A flexible item is represented with this icon. So you get your normal assembly icon in this example with an additional icon which represents flexibility. So now we have a flexible assembly, and we could constrain it at this position if we wanted to as well. Again, another thing you can do is create positional reps that activate already existing reps. So in this assembly, we may want to access positional reps for what we've just done. So you can see in this example we have positional reps that show it raised and lowered. So we can create a positional rep that accesses already existing ones. And all we do, if we wish to do this, is simply right click on an assembly, go to go to override, and then if we enable positional representation, we can tell it which one we want it to use. In this example, I want it to use halfway. So it's a really useful tool. So we talked about on the user day being able to create dynamic representations. So these positional representations are great for set positions, but you may want an infinite amount of positions in this assembly because we need to test it and make sure things don't clash. So there might be lots of different angles that I want to look at this assembly at. Positional reps would be quite time consuming if I had to check it at every 5 degrees between both the lifting and the bucket. So you can create dynamic representations by using iLogic, and we're going to have a look at how to do this. So the moment you mention iLogic, people think a lot of code and it's going to be complicated, but that is not the case. So it's really simple to do. We're going to create 2 constraints that control the bucket and the boom. So I'm going to go into my constraint command, use angular constraints. I'm going to create a constraint from the top of this face to my origin XZ plane. Now again, another command that is highly underused is the explicit reference vector, which is the default constraint. It's default for a reason. The third selection is purely a reference point. I'd recommend using this. It's the most robust of all the constraints when it comes to angles. So when we create this angular constraint, all we're going to do is name it. That is it. That's as complicated as it gets. So I'm going to call this bucket equals 0. The next thing I'm going to do is constrain the boom. And I'm going to use the origin of the boom, which is the XZ, against the XZ of the assembly. And again, explicit reference vector, I'm going to use the y-axis, so that's my constant reference point. And I'm going to name this boom equals 0. And that's as complicated as it's really going to get for us. So we're going to create now an iLogic form, and it's very simple. To create an iLogic form, we just go to our Manage tab, we have our iLogic panel, and we have our iLogic browser. If we select it, you can see it adds an additional panel which we can pick up, move, resize. It's quite flexible, so I've docked it. We have a Forms tab, and all I'm going to do is add a form on the right click. So it gives us this little form builder, and all we're going to do is, you can see that my parameters that I've just created are available because I've named them. So all we do is drag and drop to this right hand side, and you can see it starts to build our form. Again, I can rename my form. So all we're going to do is select each parameter and make one change. We're going to change the behavior from text box to slider. What that's going to do is add a slider in the dialog, but at the same time it allows me to give it properties, so I can set minimum and maximum values. So for the bucket, I want it to go from -45 to 45 degrees, and I can also set step sizes, which allows me then to give me more finite control. For the boom, I'm going to repeat that, give it a slider, and give it again minimum and maximum properties. So the result of this, if I OK it, is I have a form. If I select this button on my forms dialog, here we have it. So what it means for me now is, we're going to just have a look inside view. I can very quickly and easily dynamically change it to any given angle. So in here we can start to type in the angle if we wanted to. So for the bucket I can say 45 or 0 or whatever angle, but I can use the slider, so it gives me a lot of control to the degree. So we can very quickly, very easily, dynamically change the angle to any given angle we want. And we can then start to run tests. So maybe I want to be able to run a collision analysis. There are tools available for us to do that. Under the Inspect tab in Inventor, on our interference panel, we have Analyze Interference. So the way that this tool works is it allows us to select everything as a set or as two sets. So it's a misunderstood tool. A lot of people use everything as one set. And what I've selected, if I was to click OK, each part is analysed against one another. Whereas if I define two sets, the two sets are analysed against one another, and it doesn't care if the parts in set 1 clash with one another. So if I OK it now, we can see there's a lot of clashes between the parts. But I consider that as one set. So this time when I analyse interference, select all my parts as set 1, and then select the body or the main chassis as set 2. So this time it wouldn't include those clashes. So we can see we've got 3 interferences rather than 24. It also highlights in the browser where they are. If we expand our dialog, it identifies the parts and the volumes that are being affected in X, Y, and Z, and total volume. If we want, we can print this off to a PDF or another format, or we can copy and we could paste as text into a Word document to keep as a record.